Hello. So this is my second video on solving LeetCode problems on YouTube in C++. Today we are going to look at container with most water problem, which is a LeetCode medium problem, and it also comes a lot in interviews. So in this problem, let's start with the description of the problem. So it's given that we have got an integer array height is an array of, say, integer array, and then they like it is the elements of the height array are basically vertical lines as shown in this diagram, that if the first element is 1, it's like a vertical line of 1 length. Then if the second element is 8, it's a vertical line of 8 length. So that's how the height array is described. And now we have to find two lines together with x-axis, which forms the container, and it has the maximum, it can store the maximum water. That is like we want to choose two of the elements of the height array and find the maximum area enclosed by the two elements, the x-axis, and the height should be the minimum of the two lines. Like if one of the line is 7 length, another line is 9 length, then height of that rectangle would be 7, because you see that the water cannot overflow from the should not overflow from the smaller line, right? So we would need the height to be the minimum of the two lines selected. So essentially what we are trying to achieve here is that we want to achieve the minimum of say height I comma height j. This should be the minimum of height I, and height j should be the height of the rectangle, and this multiplied by the length of the rectangle, which should be j minus I, where j is greater than I, right? And so in order to find these value, we have to return this value in this problem. So in order to get this value, one of the method is very simple, that we iterate through every pairs of I and j in two for loops, like go through I is equal to 0 to I is equal to n minus 1 or n minus 2, and j is equal to I plus 1 to j is equal to n minus 1 for every I, and we calculate this value for every pair ij and return the maximum value. That is a very basic solution, and that would take O of n square, I would say, because we are having two for loops, and we would need to make n into n plus 1 by 2 comparisons. So that's n into n plus 2 is of order n square. So that's a very brute force approach, I would say. And like, but you need to first think the problem that we are trying to solve. So that's a good starting step to think about this problem, what we are trying to achieve, what exact value we are trying to achieve here, right? So that now, like, if we want to move ahead to optimize this problem, we have to first realize that if we have like a height I and height j, the area of this rectangle only depends on the smaller height. So if we want to find area of the rectangle between 0th element and the first element, the area will only depend on the 0th element, right? And as long as the 0th element is the smallest of the two, it will have the, like, it will depend on this 0th element itself. So like we get to understand that we have to, like, in the pair we have to find the smallest element, and also when you think you need to find a pair in an array, like if you want to find a pair having a sum n, or any type of problem which is related to having a pair in an array, you tend to think in the direction of having two pointer. So if we want to think how can we like get the solution using two pointer here, because we want to find a pair and we want to optimize it to be in one loop, like we run through the array once and we get to find that two elements of the array. So that's where the approach of two pointers comes into intuition. When we are using two pointers, we need to find I and j such that we have a deterministic approach to have the increment of I and j and like reach the state. So like in this, if we want to increase the area, we should know whether we want to increase I or j. It should not be that even by increasing both I and j we would increase the area. So normally these problems needs a deterministic approach for both I and j. When do we want to increment those iterators? So if we look here, we have two parameters which determines the our return value, which is minimum of height I and height j. One of the parameter is this, and next parameter is j minus I, that is the width, right? This is the height of the rectangle, this is the width of the rectangle. And to maximize height into width, we want to maximize we want to increase either width or we want to increase either height. If we are decreasing the width, then only possible way we can increase the total area is by increasing the height. And if we are decreasing the height, the only possible way we can increase the total area is increasing the width, right? So for the two pointer approach, we have like two ways, two types of solution that we can think of for two pointers. Is like either focus on increasing the height or focus on increasing the width, right? So let's look at the first case, that if we want to keep increasing the height and see where we reach the optimal place. So in that, like we can start with having the pair whose minimum value is maximum among the heights. Like we can take the largest two heights. Like in this case, we can take the element. Let's copy this example here. We have a height array. This right height array of. In this, we can take the top two heights. Let's say 8 and 8. That is I is equal to 1 and j is equal to 3, 4, 5, 6 in this case. If we take this, we are guaranteed to have maximized h value here. This will give us the maximum h value, right? And now if we want to increase the width in this case and see if we can reach another optimal value, we need to find which direction we should move to have like a higher value of total rectangle area. In this case, we cannot determine that because in both of the sides, the bar which we will receive here would be lower than the given bar. Like if we move to j is equal to 7, we are destined to have a height lower than 8. And if we move also to the like I to the left of 1, that is 0, we are destined to have this the height of the bar less than 8. So in this case, we do not really know which direction we want to move. So there's not a deterministic approach to have a two pointer here. Like we cannot start with taking the largest two bar and move in either direction to find the smaller find another optimal solution for our problem. So let's start with taking the highest width, taking the most largest width. That is taking I is equal to 0 and j is equal to 8. So in this, our max we have achieved our maximum width, maximum w value, right? Width value. Now, if we want to find another optimal solution, only way possible is if we increase the height of the rectangle. Now, to increase the height of the rectangle, we can move we can move in both the direction, right? But the only way we can achieve like a higher So let's see. Only way we can achieve the higher height is when we remove the lower minimum. Like if we keep the minimum value of I and j, if we keep, let's say, height I is minimum of this, then if we decrement j here, decrement j, then still the I height I, like minimum value of height I comma j will be same. Let's say that we decrement j here, still minimum of this height I comma j will be height I, right? And in that case, we are not at all increasing the height of the rectangle, but we are decreasing the width of the rectangle. So height increases, height decreases, height remains same. Sorry, height remains same in this case, but width decreases. So with this way, we will never achieve the. We will always get the smaller rectangle area than the larger rectangle area. Like we will always, in the subsequent step, we will always keep receiving the smaller rectangle area. So to uh, possibly get a higher rectangle area, we should increase the minimum height, right? So we should move forward from the minimum of the two values. So we should move like I plus plus. So now the value of min height I comma height j is guaranteed, not guaranteed, but is they is can possibly be higher than height I minus 1, right? If height I is greater than height I minus 1. In earlier case, whatever the j minus 1 height was in relation to height j, we would not have increased the height of the rectangle, and also we were decreasing the width. So there was no possible way in this approach that we could have increased the area of rectangle, right? But if we use this, that we are moving away from the minimum of the two values, then we have a possible chance that we can increase the total height of the rectangle. So our two pointer approach here should be simple, that we move our minimum value pointer towards the maximum value pointer. So at each step, we are trying to find the minimum of the two, and we are like taking if that's the optimal case or not, and then we are incrementing from the we are moving towards the larger value from the minimum value, so that we might have a possible chance to have a larger area. So it is possible that the greater value now can be the lesser value in the next iteration. So what we will do that in that case, we will decrement the pointer to the larger value towards the new larger value, right? Because in that case, that is the minimum of the two. So yeah, so this is our basic concept of having the two pointer in this case. And yeah, if we are moving both the point, like the basic concept of two pointer is like we only move one of the pointer at one time. So if we are going in a loop, we are going in either incrementing I or decrementing j. At one point they both will meet, right? And in that we will have totally covered all the n values of the array. Like I the length I would have moved and the length the j would have moved to reach a common point would be total equal to n. So the approach of this approach will take a big of n time complexity, right? And yeah, like in a earlier case also, and in this case also, the space auxiliary space complexity, the extra space that we are taking is O of 1, because we are not actually taking any structure which has got multiple elements in it. Like we are using single length variable, so that is like O of 1. So space complexity of this approach is O of 1. Now let's code this in our solution, right? So first we would definitely want to have the total number of elements in the height array. Height dot size is n. Now we define the resultant height int result, let's call it result is equal to max of height 0 comma height n minus 1, or let's start with resultant value as like the minimum value possible for an integer, and once we iterate through the array we would we would like keep increasing by taking out the new maximum, right? So let's start with int I is equal to 0 and j is equal to n minus 1, while now let's go into the loop while I is less than equal to or less than j actually, because we don't want both the pointers to be at the same place, then like width will be 0, so the rectangle's total area would be 0, so there's no point if we have both I and j equal. So let's keep the condition where I is less than j, right? And also result should be like minimum value should be 0, right? Because if both the pointers are at the same place, anyway we are going to have the 0 area of the rectangle, so not having int min is fine. Like we should have at least we are ensured to have 0 length, 0 height, 0 area of the rectangle, even if we choose both the both the uh, elements of the array as the same. So although that is not the case here, because if we choose any of the two different uh, elements of the array, we are guaranteed to have a positive area, right? So yeah, that's the case that we can move keep the value as area, so we are guaranteed to have an area which is greater than 0. So let's initialize the area with 0, right? Yeah, now let's see here what is the value of the current area that we are having. It is minimum of what we wrote here, minimum of this value. So we can directly actually do this. Current area is minimum of height I, height j into j minus I. This is actually the minimum area. This is actually the current area, right? This is the width and this is the height. Minimum of height I comma j is the height, and width is j minus I, right? Now let's see that we have got the height and the width and we have got the area of the current rectangle. Now let's see if that area of the rectangle is greater than the maximum area we have stored for our answer. So let's see, area is max of area comma current area. So if current area is greater than the already stored maximum area, then maximum area will now be equal to the current area. So this is good. uh, Now uh, we should yeah, we should decrement, we should check if height I is less than height j, then yeah, in that case we should move I plus plus, else if height I is greater than height j, height I is greater than height j, we should decrement j, right? Now the only case remaining is when both of the heights are equal. What should we do? Which pointer do we need to move, right? That is a very valid question. I should also think about it. So where that's the case, like when we have both this height is equal to 8 and this is also 8. Now we want to move, which direction we want to move? Uh, so we have greater height. I would say move in any of the direction. right? There is a possibility to have a greater height, and we are decreasing the width. And now, if we might have chosen the wrong height for that case, like it would have been possible to have something like a greater height here. Some say like like this was not 8, but this was not 4, but this was like 9, and this is 8. In that case, let's think like what would be the area of that. Let's say this was 10 and this was 8, then still the area would have been 8 and this is 10, so still the area would have been 8 into the width, right? And we are decreasing the width, so it wouldn't have affected any bit. Only case possible is if both of these two were not in the optimal solution, then only we would get a optimal solution for width smaller than the current width, right? So moving in either direction is fine, because if there is a possible optimal solution which is having a width less than the width we are having with the same length bar, then possibly then only case possible is when both of the bars are not included in the optimal solution. So that's why I for like explaining, I wrote this condition that else if. We just need a else condition, because in else condition also we don't care which direction we are moving, so just do else, right? This is our if else loop here. And we are storing the maximum area. I think now we can just return the area, and that should be it. Let's see the first constraint. What do we have here? N is between 2 to 10 raised to power 5, so it's good that j is equal to n minus 1. So always the starting point of this while loop will be valid. Like j will be always greater than I for the first time we enter this while loop. So that's validated. uh, Always area will be greater than 0, so initializing area is equal to 0 is valid. So I think this is a valid solution. Let's run this. Let's submit the solution. Yeah, this works.